All right, so what we're going to look at here is factoring something that has 4 terms, and I'm actually going to show you 2 different ways to do this. When it comes time for you to complete the problems, you don't have to do it both ways. You can pick which one you like better, but I would recommend watching the whole video, kind of watching both processes all the way through and then seeing which one you think fits you better, because there are pros and cons to both. So when we have 4 terms, the first method I'm going to show you is called grouping. And the reason we call it that is because what we're going to do is take our 4 terms, and instead of looking at it as one big problem, we're going to divide it up and look at it in 2 groups. Okay. When we do this, the exponents need to be ordered. Notice it starts cubed, squared, then just the x, then the number. So if you have a problem that's not in that order, you need to put it in that order before you group it this way. All right, then what we're going to do for each group is we're going to pull out the GCF. So greatest common factor is what that GCF stands for. So I'm looking at my numbers. I don't have a number that goes into 3 and 2, but if I look, both of these terms have an x. They actually both have 2 x's because they have an x squared. So I'm going to take an x squared out of each term in that group. So when I do that here, I'm left with just 3x. So if I multiply these, I get back to my 3x cubed. And then here I'm left with just the 2. So again, if I multiply these, I get back up to my 2x squared. And then I'm going to do the same thing here. So here if I look, they both don't have x's, so I can't take an x out. But if I look at the numbers, I've got 6 and 4, and 2 goes into both of those. So since this is a plus here, I leave my plus there. And then when I divide this by 2, so I'm factoring that 2 out, I get 3x. And when I divide 4 by this 2 I'm taking out, I'm left with 2. All right, so the only way this works is after I've done that process if my 2 groups are the same. So in this case, they are. So it would kind of be like saying so I'm going to kind of ignore where I'm at here. But if I had like 3x plus 3y, wait, nope, sorry. I'm going to do it this way. Plus like a 5x. If what's here is the same, I could also take these 2 and put them out here and make it a 3 plus 5 like this and times it by x. So basically what I'm doing is I'm factoring that x out. It's coming out of both of them. It's the same idea except instead of just 1 term in there, there's 2. So what I'm doing is I'm taking that group and factoring it out. So what goes first, or what goes in one of my factors, is whatever is the same in both groups. And then my other factor becomes what was left outside both sets of parentheses. So this is what factoring by grouping looks like. So this would be my final answer when I factor. And just as a quick check, if we did everything correctly, when we FOIL this back out, we should end up right back at where we started. So again, this is my answer, but I am going to take a minute and show you that if I multiply this out, so if I multiply my first terms, I get 3x cubed. So that was multiplying the first terms. If I multiply the outside terms, this 3x times 2, I get plus 6x. My inside terms, when I multiply those, I get plus 2x squared. And then my last terms, I get plus 4. And it's in a different order, but if we look, that's the exact same thing we started with. So this is a way that we can check our answer and make sure it's right. Again, don't get confused. This isn't the answer. This is the check. This is my answer that it looks like when it's factored. So that's the first method, and that's grouping. Set this aside and grab them and do the same problem again. But this time we're going to do it using the box method. So again, it's not different. We're actually going to see things that are very, very similar. It's just a different way of organizing it. So since it's called the box method, you can kind of assume we're going to start with a box. And what I'm going to do is put my first term, and again, they need to be ordered this way. And if they're ordered this way, I put my first term or my highest exponent here, my lowest exponent or my constant here. The other 2, it's not as important where you put them, but these 2 have to be in these places. All right, then I'm doing the same thing like I did with grouping. I'm looking for the GCF of each one. So here, if I look, the greatest common factor here is an x squared. No numbers that go into 3 and 2, but they do both have at least an x squared. And if I look here, I get that 2 goes into both of those. This one doesn't have an X, so I can't pull out an X. When I look here, I see 3 and 6, so a 3 comes out of both of those. And this time they both have an X, so I take an X out, but this one only has 1, so I can't take out any exponents along with that. Here, when I look at the 2 and the 4, 2 goes into both of those. This one doesn't have an X, so I can't take out an X. So when we do the box method, what we get on the outside becomes our 2 factors. So what that means is if I multiplied these, it would fill in that box and get me back to the problem I started with. You can also take a minute and see that's the same thing we got over here. They're written in a different order, but that's not important. When we multiply, we can multiply in any order. So those are the 2 methods. What's nice about this one, it doesn't take up quite as much space. So when you're working through, you can just kind of do it line by line. That way the box takes up a little more space, but it does provide a way to organize the terms so that you can look at it that way. One more thing that's important to look for is a GCF. So if you miss a GCF in this method, it's not a huge deal. You can always pull it out at the end. But if these terms have a GCF and you don't take it out and you put it all in the box to start, you're going to end up with the wrong answer. So it's important that no matter which method we're doing, we're also looking at that GCF to start the problem and seeing if there's anything we can pull out of everything. If you're not sure what I'm talking about there, you might want to go back and watch some of the other videos on factoring the 3 terms or factoring difference of squares or sum of square, or I'm sorry, difference or sum of squares and cubes is the other box.